And thanks to the PIXERA team and all our partners here that we get to participate in the exquisite sandwich. My name is Alex Pendleton. I'm the Pro AV Design Manager for our Pro AV Design team. I've been at Netgear for about 15 years, so you can call me the ghost of Netgear past, if you will. There's been a lot of mistakes that Netgear has made and a lot of successes, and I like to talk about them both because that's how we got here. That's how we learned, and that's how we grew into this industry. Before we get all the way into the nuts and bolts, I'm going to give you a little history lesson of how Netgear got here. We used to sell these switches, these M7100s, 7200s, and this company, Aptivision, anybody show of hands who's heard of Aptivision before? Yeah, Semtex who bought Aptivision, actually, interestingly enough. Aptivision was creating a chip called Blue River that was going to bring 4K AV over IP, low compress, low latency, a 18.8 gigabit stream into a 10 gigabit box. And they were buying our switches. We were actually building a new switch line at the time that was going to bring the cost of 10 gigabit down. So it really made sense for them to buy those next switches and bundle them with their devices as well. So we got added to the SDVOE Alliance based off of the relationship that we learned of with Aptivision. And then we went in with CV, Christie, Sony, Aquantia, and started the SDVOE Alliance as a founding member. We started getting added to a lot of large-scale networks that were streaming lots of bandwidth going up and down, and we created a system called IGMP Plus, which is an enhancement to a multicast is managed on a network switch in those networks. We learned that. I'm going to talk a little bit about it later. We also, again, knowing that 40 gigabit was our max uplink with our M4300 switches that we released in 2016, we needed bigger, faster, more powerful bandwidth. So we came out with our 100 gigabit M4500s in 2019. Then in January of 2020, trying to get in the doorway with Crestron, we were unable to. They were like, we've got you on the naughty list, essentially. We were on the no-no list. Don't buy Netgear for Crestron at all. But having Devin Kress, he had to get home, so he's not here with me today, but he's here yesterday. He was our OEM accounts manager and managed all our manufacturer relationships, got us in the doorway, and they actually tested our M4300s and finally approved us on November 2019, at Analyst Day when we were talking to our investors. So we had an opportunity really to say, hey, the #1 manufacturer finally approved our switches for AV transport. Then in September 2020, full well knowing that we needed to improve the AV focus that we had at the company, we brought a bunch of people to our offices for a council to tell us what we needed to do for the AV industry from a hardware perspective, a software perspective, and a support perspective. And we launched the M4250 series along with it, an item we called the AV UI, which was templatized AV deployments. Well, we started getting hit with a lot of people. Lighting guys were like, what about us? Why don't you have a lighting profile? So we built a lighting profile, SACN, ArtNet, and MANet. MANet was actually used on Netgear switches at the halftime show at the Super Bowl in 2023. And in October 2022, we launched our Engage controller, which we have over here on this little laptop. It's actually part of the exquisite sandwich as well. It's how we configure the switches using this system. It's a centralized controller, brings that AV UI into a centralized management way and allows you to configure the switches and utilize it in a centralized way. So you have the July 2023, we had our M4350 series, which was going to replace those M4300s that had a lot of hardware deficiencies. Again, built for IT, not for AV. So essentially there was AV stuff on them, but they had a lot of hardware problems. So to fix that, we came out with our M4350s. And why we're here today is what we launched in January 2024, which was our phase 2. Our phase 2 brought a boundary clock and a grandmaster clock capable switch, 2 switches essentially in that fabric to allow for this system today to be transported. So what are we going to do in this year? Well, I can tell you with the new products that we're investigating and the new things that we're working on, we are focused on live production and broadcast. That is what Netgear's focus is going to be, and that's where we're going to end up. With all of this history that I just explained, we've amassed an enormous list of partners. We've sent them our devices, they've sent us their devices. We've tested a lot of theirs. They've called us and say, hey, it actually just works. We don't need anything extra. And in some cases, With all of these manufacturers, we've had to build profiles into our interface to support the different types of systems and different types of scenarios that were created so that the configuration is seamless. So very large list. Just to cover the portfolio of all the switches that we currently offer for AV, the M4250 line, all 13 switches with those two little desktop guys on the far right, are offered. They're the 10 gig uplink ones. They also have a 10 gig aggregator, but their max uplink is 10 gig. But they also all support PTP transparent clocks, so they're all capable of keeping everything in time. And then we have the M4300s, which were those IT switches, a little bit older chips. I actually ChatGPT'd a soft way of saying end of life, and I got product sunset. I thought that was much better. The end of life sounds so permanent. It's like, oh my gosh, I'm killing this thing, right? Okay, and then we're replacing them with the M4350s. Now, these edge switches and core switches all have 100 gig, or capable of doing 100 gigs up to 100 gigs, 25 and 10, so you have a good platform for that. They also have advanced routing and stacking architectures, so they are a little bit more for IT as well as AV, not just the AV line. And they also have redundant power supplies and things like that, and stacking architecture. Then you have our M4500s, which are MLAG capable. Those will up 100 gig cores, 32 port, 100 gig. And there are aggregators or our core switches, and we're going to look to add to that line in the future. So what is IGMP Plus? So we'll start at the top there. So what we learned in a installation called the Cooley Law Firm is at 1 Hudson Yards, and we had that system. They had the 40 floors, 40 to the 50th floor, and as they were installing it, they realized that they couldn't continue to install and have everything flood nicely. And we analyzed the network. We took a look at what the problem might be, and there was saturation on the uplinks. There were streams from the 42nd and 43rd floor flowing all the way up to the top floors, and there was no reason. There was no subscribers up there. This is just the way it was flooding. And IGMP was actually behaving at layer 2 the way it was supposed to be, or the way it was designed. Well, we needed to fix that because we wanted to be able to scale, but to continue to use layer 2 because that is the basis of switching. Switching is a layer 2 architecture. It's focused on the MAC address. It's the most efficient method. So we first made all of the switches aware. So all of the switches in the network, spine switch and all the leaf switches, are aware where all the streams are to go. The next was we needed to build in a set of scripts that will prevent any erroneous multicast from going to the spine switch and only allow the requested stream to go across via dynamic IGMP. Once we uploaded that firmware, it solved that entire problem. And IGMP Plus became a feature that led to installations of thousands upon thousands of units deployed all across the network. So it was a fundamental change, and that's what our enhancement did. It's interoperable with all other IGMP platforms, so we can actually turn elements off, and we can turn certain elements to prevent problems with other manufacturers. We had 4 distinct links to our network at the Super Bowl in 2023. So we did have to turn it off in certain elements because those are all different vendors' switches. So to participate with everybody together, that's what we had to do. When you connect 2 switches together, we also will bond a trunk together to send all VLANs across. We'll do that automatically for you. And if you add an additional link between those 2 switches, we'll create a new interface called a link aggregation. We do that via auto lag. So yes, these are the three main features that Netgear has provided for interlinking and interoperating in multi-switch environments. There was another scenario that we needed to solve, which was quality of service. We have a platform that will work with all systems and all protocols in concert globally. And this is because we ran into scenarios where we'd have AVB or Crestron or all these other AV signals all in the same switch. And the prioritization would not be effective for, say, AVB if you did AVB, or if you were doing Crestron, it would be effective for AVB, but not for Crestron. So we built a overall overarching platform to support them all, to kind of separate the freeway, essentially, and the lanes on the switch for the prioritized traffic. You can see quite a difference between the AV type network design and the IT network design. They are different philosophies inherently. You want to restrict, isolate, prevent communication as much as possible. in the IT. In the AV world, our philosophy is that you want to open those channels for discovery purposes, for other devices to find and be able to stream and to have quick, easy communication between all of it. This system is one that we designed for a credit card company in San Francisco. It's a dual-tier MLAG configuration, and these are the size of networks that we are able to achieve, and some even bigger than this. Okay, so let's get into our implementation of PTP. We'll kind of follow up on Michael's wonderful presentation, essentially. Netgear supports on all of our switches PTP v2, E2E transparent mode, which is our transparent clock mode. Essentially what happens on the switch is ingress is essentially network speak for incoming to the port. Goes to the PHY controller, which is a little packet coalescer. It just organizes the packets before it gets to the parsing unit, which is our MAC controller. Now this little diagram shows 2 MACs, but really there's only 1 MAC controller for the entire switch. As it comes into that MAC controller, we then track the time of that packet as it egresses or leaves a port. Now that could be an uplink to another switch, could be a port on the same switch, but as it leaves, we update this correction field inside the packet so that it goes ahead and the Grandmaster clock and the ordinary clocks can stay in sync with each other, similarly to how Michael was able to show that in his demonstration. So that's how our system works. We just do an end-to-end transparent clock. For our Grandmaster clocks, the ones that are currently here in the rack in the exquisite sandwich, we have running currently in boundary mode. We have a wonderful Brainstorm DXD8 that is actually winning the election with its announced packet and it's the Grandmaster of our network. And we're in boundary modes to the rest of the endpoints that we're working with. And then we have the other one in transparent clock mode, just doing the sync to the ordinary clock. So the switches that we offer for SMPTE are the 16V4C, that's what's in the rack. It's a 25 gig 16 port switch with 4 100 gig uplinks. We also have the M4350 40X4C, which is 40 10 gig ports that are all PoE++, as well as 4 100 gig uplinks for boundary clock and Grandmaster clock mode. So where we see ourselves in the SMPTE environments, in smaller environments and medial-sized environments, we can achieve large environments depending on the configuration, but typically we are in boundary mode with an external Grandmaster clock. So a clock reference that just does Grandmaster clocking, then we are boundary to it, supporting it and alleviating that clock pressure, essentially, that can happen to the Grandmaster, as Michael explained. We don't want all that chattiness going back to the Grandmaster. We want it to hit the switch can calculate that. In boundary mode, we can do about 200 clients consistently. In our Grandmaster mode, if we're Grandmaster for the network, we can do about 400 clients in our testing and using an Ixia generator. Our best master clock algorithm to choose best master clock compares these here, similarly to what Michael explained. We'll go a little bit further though. We'll look at clock accuracy variance, then priority 2, and then go on from there. And once we choose best clock, we will go ahead and assign that clock. To look at our use cases, this would be a smaller use case. We're using, in this case, a Panasonic KC100 because this was something that we actually did in the design scenario with a KC100 when we first started testing with Panasonic. And then for intercom systems, we actually did the Video Music Awards this year for MTV, which was the largest AES-67 Reedle deployment to date. I said that was probably, this presentation was made before the Super Bowl. Super Bowl was actually bigger than the VMAs, but that's okay. So that was actually quite large. And the team that did that, they were very happy with the success. They're going to move forward and build an even bigger one for next year. So this is the type of deployment that we see is benefiting the lower end and the smaller end of these systems. And then for the larger SMPTE network, for right now, what Netgear's offering is for the SMPTE network is at the edge of these large networks. We are not going to be the core of a large network with the current offering. However, like I said, Netgear's a public company, so what I'm about to say could change, and we don't give roadmap, so take it with a grain of salt. We are investigating a really, really large system that will benefit as a core in these SMPTE networks. As you can see our trajectory, that's where we're headed. So how did we know we were able to do this? Well, when we first designed our M4350 that had boundary clock / grandmaster clock capability, we put it in a system in Japan that was brought to us from an integrator named Astra, or manufacturer named Astra. And they were setting up a telestream as the grandmaster. You can see here this SBG 8000, very fantastic reference clock. It was connected to us via 1 gig fiber, and then it was sent over to this Astro Design IG5114, and then we were using the management of the KC100T. As soon as we plugged it in, the very first shot, it was successful. So at that point, that led to a partnership at that moment with Panasonic going forward. We would share information of how our networks are built and what they're involved in. And we also did an installation at YTV in Japan that was really, really successful. We're actually building 2 more with them, 1 in Canada and 1 in Germany. So often when I present about SMPTE and Netgear, I get the pushback that NMOS is not an API that we support. And it's true. Netgear will not interact and we will not change our routes if you send us a request from NMOS, no. However, if you pass NMOS and you don't need us to change the routes, and the endpoints themselves can change their route to us, we will support the dynamic join. We will not support the static join. We will also do the peer-to-peer discovery, as we were able to do that at our ISC booth this year. We were able to do P2P NMOS without issue. I call it the big bad wolf because it seems like every time we talk about it, someone says, oh, well, you don't do NMOS, so you can't do SMPTE. Well, there's the exquisite sandwich, and it's doing SMPTE. So, proof is in the pudding. If we do transition into this new style of network, you'll see that it is just as well, just as good as the static join that we will see. And as long as the NMOS is passing and is able to register the devices and the endpoints, all will work out. So, to introduce you to my team and what I call the A team, this is Laurent Mazia. You could call him the godfather of the Pro AV design team, godfather of AV at Netgear. We all came together, IT professionals essentially adopted into the AV world to support the AV and broadcast personnel. Also, the A team in the US is Stefan, Nicole, Casey, and Ryan. They are on my team. They support everybody coming to us in the North American territory. Soon we'll get Michael Deck from Ireland, so we're pretty excited about him. He's going to be in the Eastern Coast. Also very exquisite AV and broadcast engineer. And so with that, I will take your questions.